This is for Year 12 methods, and it's the composite functions number 2 in the series. If f of x equals x squared minus 1 and g of x equals the square root of x, determine if f of g of x exists or g of f of x exists, and find the resultant function and its range and domain. So, to test to see if the functions exist, we need to find the domain and range of each of f and g. So, f of x is x squared minus 1, and I've sketched it. The domain of f will be all real numbers. The range of f will be -1 to infinity, inclusive of -1. The domain of g will be 0 to infinity, and the range of g will also be 0 to infinity. Okay. Now our test to see whether fog exists is it goes through g first, so the range of g has to be a subset of the domain of f. The range of g is 0 to infinity. The domain of f is all real numbers, and it is a subset, so fog of x does exist. Let's check g of f of x. The range of f is -1 to infinity, and the domain of g is 0 to infinity, and there are some values from -1 to 0 in the range that will not fit in through the domain, so it is not a subset of the domain of g. Therefore g of f of x does not exist. Okay, the second part of the question then was to work out the domain and range in the actual function. So f of g of x is going to be g sitting inside, so the square root of x all squared minus 1, which will give you x minus 1. The domain of f of g will equal the domain of g, the original function, and that will be from 0 to infinity, and we can only find the range of f of g if we actually have a look at the graph. There's no other way of working out the range other than considering the graph. So my graph will be from 0 to infinity of x minus 1, therefore its lowest range value will be -1 and its highest will be infinity.